All right, now that we've learned how to solve logs, let's put them to some actual use. One of the uses for logarithms is when we have exponential growth or decay and we want to solve for the time. So this is a typical exponential growth formula. The A value is either the future value, or sometimes we call it our total amount, and the A0 is our initial value, or our starting amount. R is our rate, and we always put that in decimal. K is a growth or a decay constant, depending on if we're talking about growth or decay. And T is time. So the first example I have is over at the King's Farm. They have a grasshopper infestation. Initially, it infects 100 acres of their farm. Every week, the area of the land they overtake doubles. The growth constant is 0.7. How long will it take before the grasshoppers affect 5,000 acres of neighboring farms? You know, just one grasshopper's kind of cute. Okay, so let's put that into our formula. We want to know how long, need the pen. We want to know how long it takes for 5,000 acres. It started out with 100 acres. Our rate is it doubles. Our growth constant is 0.7, and we're looking for the time. Well, the first thing I want to do to solve this is divide both sides by 100. Right? I can't multiply by 2 first because that messes up the order of operations. And that leaves me with 50 is equal to 2 to the 0.7t. Now I have this exponential here, and I have everything isolated from it, but I have to bring down my exponent, and I have to undo this base at 2. So I'm going to take the log of both sides. And that brings my exponent down. Oops, that's not equals, it's times. Okay, now I still need to isolate the t, and I'm pretty good here because the log of 2 is actually a number. So I can divide both sides here by the log of 2. And when I do that, I get that the log of 50 divided by the log of 2 is about 5.64. It's important, I'm rounding because I'm writing this down, but it's important that when you're using your calculator to calculate this, you don't round until the very end. And then I can divide both sides by 0.7. So you take the last answer, divide it by 0.7, and I end up with the time being 8.06 weeks. Yikes. 2 months for grasshoppers to overtake the surrounding farms. All right, next, I want you to try this one. Fungus in the fridge. Unfortunately, your little brother left some cheese in the back of the refrigerator and no one noticed until it turned into a lump of icky mold. If the mold grows at a rate of 10% per week and the growth constant is 0.2, how long will it take for the amount of mold to double? Give this a try. Pause the video, and when you're ready, restart it and check your answer. Okay, so You might say that you never told me how much to start with and how much double is. Well, it really doesn't matter what value you start with, so it's probably easier to start with whenever I have a doubling or a half-life problem, or tripling, whatever I start with and end with, the ratio is going to be 1 to 2. So it's easier just to use 1 and 2. My rate is 10%. My growth constant is 0.2. And then if I divide both sides by 1, I still end up with 2. And then the value here at the base of my exponential becomes 1.1 to the 0.2t. I'm going to take the log of both sides. Oops, I forgot to bring the 2t down. That goes down there in front. Just fits. I can divide both sides by the log of 1.1. Alright, and then I get 0.2t equals 7.27-ish. Again, don't round until the very end. And I divided by 0.2. That means that t is about 36.4 weeks. That's how long it would take for mold to double in your fridge under these circumstances. How long would it take for mold to completely overtake your refrigerator? All right, let's try a couple of exponential decay problems. So we have the weight of radioactive material remaining after some number of years is given by A equals my initial value times 2 to the negative 0.0001 t grams. When will it be half its original weight? And you'll notice here that my K value is negative, and that's because I'm working with exponential decay. I don't know how much material I started with, but I know that I want to know when I have half of it left, so I can use that ratio. All right, and that when I divide by 1, I still have 1/2. And then I'm going to take the log of both sides. Divide both sides by the log of 2. The log of 1/2 divided by the log of 2 actually works out nicely. It's -1. Don't even need a calculator for that, because 1/2 and 2 are both powers of 2. And then I divide both sides by negative 0.0001. And I get that t is 10,000 years. That is why, kids, we don't play with nuclear material. Okay. When a CD, I want you to try this one. When a CD player is switched off, the current dies away according to this formula. I, which stands for current, equals 24 times 1/4 to the t. How long will it take the current to reach 4 amps? I'm going to guess that's in seconds, knowing what I know about electricity. So go ahead and pause this, restart it when you're ready. Okay, so we want to know when it reaches 4 amps. All right, easy. I'm going to undo the 24 from both sides first. And I get 1/6 is equal to 0.25 to the t. And I'm going to take the log of both sides. Divide both sides by the log of 25. and I end up with t is about 1.29. And since I'm guessing that's seconds, I'll just go ahead and throw that on there. All right, and a subject I'm really interested in is money. So we have the compound interest formula. It's almost the same as the other exponential growth and decay formula, except that, I have A, my future value, P is my principal or my initial value, R is the rate in decimal, but you'll notice I have it's divided by N. N is the number of compounds in a year. So there are different amounts of compounding that can happen with compound interest. And T is the time in years. So the number of compounds can be almost anything, but these are the common ones. We have in a period yearly, sometimes it's called annually, and sometimes it's called per annum. That means the number of compounds is 1. Semi-annually is 2 times a year. Quarterly would be 4 times a year. Monthly would be 12 times a year, and daily is 365 times a year. All right, so let's do an example. How many years will it take an investment of $5,300, earning 2.9% interest compounded annually, take to have a value of $8,000? So we want to end up with $8,000. We're starting out with $5,300. Our rate is 1 plus, and we need to change that to decimal, 0.029. It's compounded annually, so this is over 1, which I don't really need to write it, but I'm doing it just for the heck of it, to the 1 times t. All right, let's simplify that. We have 8,000 equals 5,300 times 1.029 to the t. And then I'm going to divide both sides by 5,300. And when I do that, I actually end up with an ugly number, 1.509-ish. Don't round again, equals 1.029 to the t. Bring down your exponent by taking the log of both sides. Use your last answer, don't round. Divide both sides by the log of 1.029, and t is about 14.4 years. All right, so I need a new sewing machine because 4 sewing machines just aren't enough for one person to have. I have $5,000 I can invest at 5.4 compounded monthly. How long will it take me to earn the $12,500 I need to buy a machine? So I want to end up with $12,500. I only have $5,000 to start with. My rate is 0.054, and that's compounded monthly. And so monthly compounds are 12 times, and that gets multiplied by the time as well. Sorry, that was Jamie's alarm going off. It is 5 a.m. All right, the first thing I'm going to do, I woke up because I was dreaming about my sewing machine. First thing I'm going to do is divide both sides by 5,000. That leaves me with 2.5 on this side. The other thing I might want to do is calculate this ahead of time. That is 0.0045. So I get 1.0045 to the 12t. All right, I need to take the log of both sides. I'm going to go ahead and divide both sides by the log of 1.0045, and 12t ends up being around 204. And then when I divide by 12, t is about 17 years. Oh, that's so sad. Okay. Here's one for you to try. You invest your allowance of $270. It earns 15% compounded annually. How long will it be before you have $1,000? Give this a shot. Turn this back on when you're ready. Okay, you want to have $1,000. You're starting out with 270. You have 15% compounded annually. I'm not going to put the 1 there in that case. Going to divide both sides by 270. That gives me roughly 3.7. Oh, I'll write the 04. That's an estimate. Equals 1.15 to the t. Take the log of both sides. Divide both sides by the log of 1.15. Remember, don't round this answer. Use the answer button and then divide by log of 1.15. That means that t is about 9.37 years. Okay, last one. How long before your investment of $18,100 at 13.6 compounded quarterly doubles in value? Give this a shot. Pause the video, restart it when you're ready to check your answer. Okay, so let's do this. Doubles in value. If I I'm going to go ahead and write the rest of this first. 0.136 divided by 4 to the 4t. I could calculate what double this is. It's 36,200 relatively easily. And divide both sides by that, but that leaves me with 2. Since I know I'm doubling it, I could skip all of that. And just do this. Because the ratio is the same between 36,200 and 118,100 and 2 and 1. That's a nice trick to use when you're doubling. Okay, so 2 is going to equal 0.136 divided by 4 is 0.034. To the 4t. And then I'm going to take the log of both sides. Divide both sides by the log of 1.034. Leaves me with 4t is about 20.7. Divide both sides by 4, and I get t is about 5.18 years. You'll notice that didn't take very long compared to some of our other problems, and that's because we have a high interest rate. All right, that's it for today.